Hey, I'm Josh Lebowitz. I'm a product marketing manager at Komodo. I am joined today by Zach Forsyth, the director of product strategy at Komodo. Zach, great to have you here. Thanks so much for being here. Really appreciate that. We're going to be talking about Komodo Dome, which is one of your babies, and I'm going to give you an overview of the product. We're going to do a Q&A at the end of the show through our chat function. We'll be doing a walkthrough. One of our SEs, John McIntosh, will be walking us through the UI and such. Before we get to that, what is Komodo Dome? Let's discuss what is this incredible product. Give us the elevator speech. You're in a short building. What's the elevator speech for Komodo Dome?
Yeah, obviously it's a very advanced product, so we could talk about this for days, but the very short sort of introductory sort of explanation of what it is, it's a next generation secure web platform that's designed to protect any device, any user, any location, and what we'll do is we'll take the traffic and essentially do URL filtering, something we call portable containment, which we'll touch on later.
Right.
And we can provide protection against even unknown malware, full protection on an endpoint, as well as do things like anti-spam, bandwidth control, cloud VPN, all sorts of really cool stuff that we get into.
There's all sorts of stuff. Yeah, this thing is it's packing a lot of power in a lightweight package, so that's cool. So first, let's talk about how Dome fits into Komodo 360, which is our specialized threat analysis and protection compliant, STAP compliant, end-to-end full-on security protection solution. Where does Komodo Dome fit into the Komodo 360 story? Yeah,
so it's a great question. It's actually a very integral part. The Komodo 360 vision is that there's three areas you need protection. It's the boundary, which is where Dome fits. Right. It's the endpoint, where our advanced endpoint protection fits, and it's also the internal network. So you need those three pieces to actually provide full coverage across all your devices, locations, systems, no matter where they sit. So Dome sits at the boundary, it's the perimeter, it's the first line of defense. So you need something there that can actually provide protection against malware and ensure that the users, as they're browsing or sending traffic to the internet, are actually being protected.
Okay, makes perfect sense. Excellent. Thanks. Okay, so let's assume I know nothing about why we need a perimeter solution, which is not that far off from the truth. Why start at the perimeter? I mean, it seems sort of obvious to you probably, but why would we start at the boundary rather than, say, the endpoint?
Yep. So defense is all about layers, and obviously your first line of defense is going to be one of the most important. So Dome is protection closest to the source of your attack. So if you could do all of your defense there, that's probably the best solution, because then as you fall back through your layers, you're obviously going to catch more malware. So Dome sitting at the perimeter is really important, and it's actually going to provide far more protection than a signature-based antivirus sort of web filter that a lot of our competitors have, using Komodo containment, portable containment, and Valkyrie, our file verdict platform.
Okay, want to tell us a little bit about, not everyone may know what Valkyrie is. What does that mean exactly?
Yeah, so Valkyrie is our analysis engine, you can think of. It sits in the cloud. As someone downloads a piece of malware, we actually look up that file in Valkyrie and decide whether it's known to be good, known to be bad, or whether it's a totally unknown file.
Right.
And if it's classed as an unknown file, we send it to Valkyrie. It gets executed in a sandbox so we can see if it's actually malicious, what its behaviors are when it thinks it's running on a system, as well as doing some static and dynamic analysis of what that file's actually doing, looking at the metadata, and eventually even going off to expert human analysis, where someone puts hands on, tries to reverse engineer the code and see what's actually happening.
Wow.
So we can provide a very thorough and very detailed sort of identification of whether something's malware, even if it's time-bombed, even if it has anti-sandbox sort of evasion technology built into it, we can actually still tell that a file is bad, good, or unknown.
Okay, and so for those unknown files, let's talk about what makes all of the sort of Komodo protection technologies really rather unique, which is the containment portion of the program. Tell us a little bit about portable containment and about our sort of lightweight but very, very robust containment solution.
Yeah, containment is a bit of a radical shift in thinking about how we treat files. So in a traditional antivirus system, everyone does signature-based detection. So do we know if this file is bad or not? And then they do a little bit of what we call heuristics. So they try to make intelligent decisions based on what's already been seen to decide whether that's actually malware or not. But what we're trying to say with containment is we're going to say files are always going to be known to be good, known to be bad, or they're going to be totally unknown. Could be a good file, could be a bad file.
Right.
But let's assume that sometimes files are always going to be unknown. What happens then? Most antivirus solutions and web filters that sit in the cloud or on premises actually let those files through because they're not known to be bad.
Right.
We're saying let's treat those files as totally untrusted and do something called containment. So when we see that file that's an unknown, we actually put a little wrapper around it and we still deliver it down to the endpoint. Right. But we let that run in what we call a container, or you can think of it as a jail. Right. So there's actually no way for that piece of malware to escape the jail and to infect the host-based system. So you end up with full productivity for your end users because they can still use the application, right. But you have full protection because it can't affect anything sitting on the operating system itself. Right. And as you mentioned, it's extremely lightweight, doesn't have any CPU dependencies, things like that, needs very minimal amount of RAM, only adds about a megabyte to the file size. Right. So it's sort of like, I'm not going to call it the silver bullet, but it's a radically different way of actually looking at malware and deciding how to treat that malware.
Right. And I think when so many new malware pieces are being created on a daily basis, you can't keep up. Your whitelist and your blacklist, they're just going to be hopelessly, your blacklist especially, hopelessly out of date every day. I mean, every every time you make that list, it's out of date already because so many more malware variants are being cranked up every day.
That's a great point, and that's one of the critical pieces to our assumption that there's always going to be unknown files. Right. Like, let's forget about the arms race against malware to see who has a signature to detect everything. Let's just assume that we can't detect if something's bad or good. We just don't know what it is. What then? What does everyone do? Well, we contain it, which we think is the perfect solution.
Right, and then we judge it very, very quickly. The Valkyrie system is the fastest out there, as far as I can tell.
So in parallel with the containment, we send it to Valkyrie. We usually get a verdict back within about 45 seconds to tell us whether that file's good or bad. And then the second time it gets downloaded or run by the same user, we already know sort of whether that is a file that should be allowed full access or it should be totally blocked.
It's now known good or known bad.
Yeah.
Right. And 45 seconds is 10 or so times faster than our nearest competitor, is that correct?
Very rapid. And the important reason there is that you don't want things to stay in containment. A lot of our competitors offer a micro-virtualized sort of environment where all files run, but they're always contained. So you obviously have productivity issues.
Yeah,
there.
totally. CPU draining and all that sort of, I mean, it's just things going to slow down.
We just want things in containment for the shortest time possible because if it's actually a good file, we want to make sure the end user can use it and remain fully productive throughout the day.
Right, fantastic. Okay, so that sounds very compelling, actually. So if you had to sort of sum up, why Komodo Dome? Why this perimeter or boundary defense solution versus others?
Yep, so it's that radical shift in treating unknown files as untrusted rather than saying, if I don't know what it is, I'm just going to allow it through the system, allow it to run on the endpoint.
Right, that seems like a recipe for disaster. The default allow seems like a recipe for disaster, whereas default deny, which is what we're doing, is your safest bet by far. You can still use those files, but you can't. But they can't infect you. If they do turn out to be malware, they can't do what they're designed to do, which is infect you, thanks to our containment system.
Absolutely, and it's something that we need to, sort of look at as far as all these emerging threats. The technology in the malware world and the advancements they're making writing malware are outstripping traditional antivirus, and we've seen that for years. The effectiveness is going down and down and down, and everyone's trying to bring out slightly new heuristics and machine learning. But let's just make that assumption. There's always going to be some files that you can't actually determine what it is. So once you make that assumption, you can build a piece of technology like containment that actually takes care of protecting a device.
Yeah.
So it doesn't matter what new strains come in the future, we're still protected.
Outstanding.
It also doesn't matter if there aren't any signatures. It doesn't matter if the piece of hardware is old or brand new or just provisioned. We're still protected in all instances. It's a really important assumption.
That is very important, I think. A game changer, actually. Terrific. That's awesome. Okay, we're going to take a quick break. We're going to send this to John McIntosh, an SE, to sort of walk you through the UI for Komodo Dome, and we'll be back to take your chat questions.
Yes.
Zach will be able to answer those through the chat functionality on the bottom of your screen or at the lower part of your screen. So over to you, John. We'll see you in a sec.
Thanks, Josh. Let's look at this brief demonstration of some of Komodo Dome modules. As discussed earlier, Dome is a pliable and modular secure web gateway platform. which has the ability to do firewalling, anti-spam, advanced threat protection, sandboxing, portable containment, data protection, fully meshed VPNs, and other features like bandwidth management and URL filtering. Traffic can be routed into Dome via VPN tunnels from PAC files, direct proxy settings, or even a Komodo agent itself. All of these features are visible within a single pane of glass through the Komodo One administrative login. Here you can see I have Komodo Dome, anti-spam, firewall, web security, and data loss prevention components. Let's take a quick look at each of these. Komodo Dome is a URL filtering and web security platform that provides blocking of URL categories, portable file containment, and very advanced malware protection. You can see here we have a range of reports showing the top targeted domains, URL categories, etc. Any of these can be drilled down on to get more information, including user-based information and deep context around security. We can see the top sandbox files or wrap files where we use portable containment to ensure that unknown files cannot run on any system. There's a full in-depth analysis of all downloaded files to our Valkyrie platform, and here we can see detailed analysis of each file and whether this was malware or a good file. We also have a fully fledged firewall. We can do very advanced rules around quality of service, advanced threat protection, IDS, IPS. We can categorize traffic and build VPNs into Dome itself, so we could have a fully cloud meshed VPN and apply full firewall protection for site-to-site VPN traffic. You can see here a few rules allowing SSH traffic, SMTP, and LAN to internet traffic to flow. There is a full SSL VPN server, a full IPsec VPN, and an L2TP VPN for Android and iOS connections. We also have a full-blown email protection service that includes anti-spam, malware protection, containment, and we can have multiple domains added. As you can see, we have spam that's been whitelisted, blacklisted, viruses, and this is a very full functional spam service, which includes global quarantine. It also includes archiving and disaster recovery options, where all end users can use a web-based email to log in and get their messages while messages are being spooled in a disaster recovery situation. Once your servers are back up and running, you can then redirect or resend that traffic down to your on-site email servers. We also have very advanced DLP functionality that can protect data at rest and data in motion, including an endpoint agent that can protect you against your users trying to copy data to the clipboard, to USB drives, printers, and also do some very advanced partial file matching. If someone tries to copy page 3 of a document and send that, we can actually block the transfer. So let's have a look at Dome in action. I'll switch over to Firefox, and I will try to go to a website we shouldn't be allowed to go to. And you can see we instantly get the block page, and we're not allowed to go to that site. Whereas other sites work perfectly and work quickly. You can see there is quite low latency, and we can browse safely on the web. The most important thing Dome does is actually block you from getting malware. So let's look for some new malware and download it. I'm going to just download one of these executables. This file could actually be a known good file. It could also be a known bad file. You can see here this one appears. It could possibly be known good. We can save this file. If we look back quickly, we can see that this unknown file is 21 megabytes in size. We can see here it's approximately 21 megabytes. We can see that the description is Komodo Sandbox, so we know that the file has been portably contained and can be run on the system without any fear of being compromised. If we run this file, we see that it is running. We should see CPU and memory activity, and even though the file is most likely malware, we can see that it's actually been contained because it's classified as an unknown file and should not be allowed to run by itself. Once we kill the sandbox, the file is gone. Let's try to download another one. This one is a known good file. We can see it is not wrapped by Komodo. We can also demonstrate some DLP capabilities by going to My Documents and try to copy some credit card numbers. And we can see that this instance has been blocked. If we look into My DLP logs, we will be able to see a quarantine rule, the clipboard rule, and we can get more details here. We can see exactly which system, what time, the user, why the rule fired, and we can actually see the file and the pattern match, and even download the SEEP data itself. Thanks for watching this demo. Josh, back to you.
Excellent. Thank you, John. Nicely done, by the way. And I guess it's going to wrap up the video portion of the program, but we are just about to start the chat portion. So Josh Lebowitz signing off. Thank you very much, Zach. Excellent to have you here.
Pleasure.
That was fantastically done. Nice overview of this rather remarkable product. So any questions you have, if you haven't typed them in already, feel free to use the chat function, and Zach will be able to answer your questions that way, through that mood. Thanks so much for being here. Appreciate it. See you next time.